At what angle above the horizontal must the gun be aimed to achieve maximum horizontal range? Yes, again, only the speed of the maximum range of a shell fired from a gun is R equal to 22.5 meter. This gun is mounted on a platform. I think there are two different things are there. On ground, when I fire it, this particular, there's a gun. When I fire it, it's going to have maximum range. And this maximum range, I'll call it as RGM or R with respect to ground. So this value is how much it is? 22.5 meter. Okay, this, so now what is this R max? R this should be equal to U square by G. So therefore U, I'll get it as root 25. There's the initial speed. Okay, now I know velocity of trolley. I'm going to project this at an angle. Let me call that as phi. Earlier I used theta, no, let me take that as phi. So now as the trolley is moving, so therefore the speed of the ball will become relative to the trolley. There's a background. So what is the time of flight? Time of flight will be same, 2 UR sine pi by G. Then for the maximum range where? On the ground or on the trolley? When it doesn't mention anything, what we should take with respect to ground. When you project from a moving trolley, what is the maximum range it will attain? That's what our question is. So therefore, let me enter into the problem. First, time of flight. Okay, there's the initial part related to earlier data. Okay, the time of flight is given by 2 equal to UR sine phi by G. Then the range before that, along x-axis, UR cos phi should be equal to velocity of the ball with respect to ground along x-axis minus velocity of trolley with respect to ground along x-axis. Okay, this will be UR. Do we know UR? Okay, we don't know UR. Let it keep. Do we know cos phi? We don't know that also. We know velocity of trolley. So this, we know only velocity of trolley. This I'll write it. Vtx equal to Vbx. Now what is the range? Range should be equal to Vbx into time of flight. I'll come to this part here. Let me write, I have space. What is Vbx? So UR cos phi plus it is plus Vtx. Time of flight will be 2 UR sine phi by G. Range is equal to 2 UR square sine phi by G plus let me differentiate this dr by d phi equal to 0. Anybody, what shall I write UR? There's a big question mark. Huh? What shall I do with UR? We don't know UR, no? The gun, see, it should be 15 only. See, earlier the gun was on ground. That was absolute velocity. Now on the moving trolley, it will fire. It will fire. It will have the same. So like I think you go back to the muzzle speed. I think I should use word muzzle here. I should use word that muzzle speed. So when the gun is cos phi term,
expression sin phi cos phi.
okay, one cos phi. Yeah. Okay, now I'll say that this is a muzzle speed of the gun. Since the gun is fixed on the ground, the muzzle will become absolute velocity. Now it is kept on moving trolley. The muzzle speed now what will happen will be UR only. So therefore that UR is what will be 15 only. So what we call muzzle speed it is. When it is on the ground, it will become absolute velocity. When it is on the ground, no, it will become absolute velocity. On moving trolley, it will become relative velocity. Are you able to get this? So muzzle speed, you write it on ground, fixed on the ground. This is, I think, very important. I think now rest, you know, your value all differentiating this. Anybody value phi? I think some quadratic will come.
60 degrees.
60 degree. Yeah? What is actually here? So it is going to strike on the ground. So what should be the trajectory? The trajectory should be with respect to ground. It should be like this. This is what that range with respect. After this, okay, trolley will be there. I'm not bothered that one. The trolley will be somewhere here. Maybe if it is a long trolley, it will strike on the trolley itself. So I'm not bothered. The trolley will continue to move it. Okay, this is what that range that is being asked. So this has to be maximum. So what is that R? R is this particular thing. This has to be maximized. I think this is very important for army, no? So usually battle tanks. So it's a very fundamental question, not something like a, so in battle tanks or pen, so that particular maximum range can be obtained, not 45 degrees. If the tank is at rest, maximum range 45. When tank is moving, you should bring this particular angle.